Next up is Edmund Sutcliffe, who's going to talk about the cargo cults of build. I'm really looking forward to this talk because, like, also from personal experience, I've seen that, like, for example, Bazel projects that use lots of Starlark, lots of build files. It's pretty easy for those kinds of projects to turn into one big copy paste disaster. So
I think we all have worked on projects where there's too much copy paste and too much wipe away of history, where it becomes the killing of you, the death of you.
Yeah, there should be more deletion. That's what I'm opting for.
I'd vote for that. More deletion of all sorts of things.
So, Edmund, good luck. I'm going to keep an eye on the chat to see if there are any questions.
Let me begin with talking about what we're going to talk about. What's a cargo cult? Fundamentally, a cargo cult is where one performs the actions perfectly, expecting the same results without understanding that the actions have meaning. A really good example of this is the way that people repeat the act of just we'll power cycle the machine and it will come back to as it was without understanding what's locked behind it and what those implications are. What really is the problem here? What's holding these things together that's getting us to the cargo cult? Well, I guess the first thing we should say is we're really bad at writing software. We're amazingly awful and we're not getting better. There are good studies, famous, well-rounded studies, looking not just at the finance industry, but across a whole range of industries where certainly projects are typically over budget. They never deliver on what they want to do. And in recent life, for me, these projects have actually been so badly implemented, they've risked the future of the business simply because they cannot get the software together. It's not just the process of writing the software and the software development lifecycle, but actually we embed bias into the decision making and we cripple the people in business by doing this embedded bias so much. I'm just finishing working on a project for one of the big 5 consultancies, and there's so much sunk cost into this project, they can't actually own up that it's going to bankrupt them, and certainly the long-term impact for them will not go well. We have all of those things about the bandwagon effect. I think certainly in my career, I've seen lots of people jump on the back of particularly software construction tools, the continuous integration, the continuous delivery thread, and said, well, we'll just implement them and everything will be okay as a result afterwards, without actually understanding the underlying need for them and what they're to resolve in that delivery. Those biases in the end just make this risky business still harder for that delivery. What we've developed is this cargo cult around the actions and tooling we use to deliver software. A really good recent use of this is the fact that we have confusion between the technology that a container delivers and why that may be of value, and the implementation of it, for example, Docker. I've spent nearly 6 months this year explaining to people that Docker has not gone away, but you may want to think about it in a more usable, more flexible way in containers and understand that a common markup for those and OCF around those actually give you a better end. But also, it's not just about that tooling, it's about the approach. I began my career in software development actually at Sun Microsystems, and I worked down the hall from James Gosling. And when we were looking at that software development in my end of the business, which was close to the operating system, we were tied to Make. And in fact, the early Java builds were all tied to Make because they came from the same SDLC workshop that we worked on. But now no one would imagine using Make on Java. The development of tools like Ant and Maven and Gradle, and even Bazel, has changed the way we think about this. But with Bazel, we're returning to many of the stories we've learned with Make and some of the disasters we've had with Gradle. They're not perfect. But again, this is a situation where people have bought into the cargo cult of a particular tool without understanding what they're doing. And by tools, I don't just mean the software tools. There's an excellent paper by Paul Sherwood called The Emperor's New Scrum, in which he talks about the processes. People jump on board during this software industry development cycles with yet another thing. This group of people, I'm working in one of the large consultancy companies, has decided that Scrum won't work for them and they must use squads. And squads is the future. This is yet another example of a cargo cult, people jumping on the bandwagon bias that they have without understanding what's going on. There's a halo effect about Spotify that are bringing people to do this. And the same is happening around particularly things like build tools. But we shouldn't just blame the tools. Let's think about the humans. I mean, we're learning that we're actually bad at doing this recognition about what our difficulties are in handling these things together. I'm sure on this platform, everyone is familiar with Malcolm Gladwell's Blink book. And one of the things he makes a point out of there is you see something wrong, it gives you a gut punch that you shouldn't be doing that. But there's very hard time explaining it to others. And actually that means resolving that difficulty becomes difficult. Daniel Kahneman's Thinking Fast and Slow really looks at it from an economic viewpoint. And remember, software development is an economic viewpoint. And that problem of the emotive gut reaction, I'm absolutely guilty of this. I jump on board things thinking, it feels right to me, I should go in those directions. But actually, if I take that deep breath and try that analytical and reasonable approach, actually, my gut reactions are not better than 50-50 right. And that's a problem for humans as a whole species, and for the problems we address on the whole. This has become such a problem that in key industries, they are beginning to deal with these cognitive overloads with where people think they've answered the questions about delivering things with checklists. My partner spends her life in hospitals chopping people's bodies to pieces. And there's a thing called the WHO surgeon's checklist to make sure that all of the right things go into the body and are counted out of the body during surgery. They do this because we have this emotive reaction of we're doing the right things, but in fact, we're not addressing the analytical, and having this extra stop in the way makes us think about these things. There's a whole bunch of embedded biases into the process. I'm absolutely guilty of this as one of those things. I continue to believe that I should be able to destroy things and recreate them. The problem is, does that give me binary consistency? Or does this give me a headache in managing the binary consistency? And in fact, all I need is functional consistency. I have an embedded bias about wanting binary identical results, when in fact, maybe testable evidential reports are good. There are problems with evidence. As we start constructing these things and handing them over to people, people are wanting to know that we've done well in the constructing and delivery of systems. Actually, this is played out differently around the world in the legal frameworks. The UK Law Commission in 1997 assumes that a system is functioning unless there's explicit evidence against it. So in fact, very recently in the UK, with the Post Office Counters Limited case, in fact, what we have is we have a system that, though it was verified, that is to say the software test passed, and it did what they thought it did, it turned out to be stealing money from itself, miscalculating the final registration of them. And because no one had validated whether that was possible for the system to do, a whole bunch of people went to jail, 30 of them. This High Court case and now Supreme Court case in the UK certainly is going to change this. It will change, I think, the assumption that a system functions as explicitly told, and actually will need us to provide evidence that we can validate the verified test results as it goes on. In the United States, the law is slightly different. Withholding information about the evidence gathering techniques, we can simply say, our experts say. I think that's going to change, and I think it's going to follow the way that it has in the UK. and it's going to place these problems on us, so that when we build systems, we actually have to have reproducible build systems, and we have to be able to say that they give deterministic responses and they've covered them, not just for the build system, but for the software that builds through it as well. So are we really in a cargo model situation? Are we in a situation where we're not applying science to this problem, allowing us to validate the model and making it useful for prediction? I think we are. The question is, where can we find models that let us address this as a problem? There are certainly models that exist for complex environments. Software development life cycles and build in particular, the construction of software in particular, is something that we could build complex models for. NATO has, since the mid-80s, had a thing called the modern battlefield warfare model. And the model is rich and understands the supply lines and implementation of warfare on the battlefield. Interestingly, just this last week, Google has come forward to announce that it's been using systems theory predictive analysis, STPA, for complex problems. But interestingly, there's no evidence that they've used this to look at their SDLC, or worse, that their construction and delivery of software. They've just said, oh, well, it works for us. It's got faster. We think it's coming out with more product. But the evidence around this, without a model to let us confirm that, simply says, well, perhaps we're fooling ourselves. So what would a model help with? Why aren't we addressing this? Oh, from the initiation of a system to the deprecation of the system, the whole model would allow us to understand where optimization could be done, not just in the construction, not just in tests, but in validation, not just in the business, in extracting the desired from the stakeholders, but on the intent and the business analysis, and also the whole validated return. It lets us navigate better and predict issues during the whole cycles that hold this together. And particularly as these cycles become the heart of legal test cases, being able to show that we've done them and report on them will become important. It's not just good enough to say we did 10,000 of them, but we have to say 10,000 of them returned valuable, validatable, verifiable results to hold them together. As I look at construction systems, and particularly how they hang together, there are some things that immediately come from my type 1 thinking. They get to the gut of what we're doing. We can fix a small bug, but in fact, that breaks the whole system. As we just heard from the Arriver guys, small changes have big impacts, and actually verifying those to assist the system delivery actually becomes a problem. But do we understand that for the software development system itself? Are we just assuming we know it's good enough? We're getting better at doing this for software, but are we doing it for the software tooling? We've got very good at managing the dependencies in the software construction, but are we actually mapping those dependencies all the way back to where the impacts are from the supply chain? The Linux Foundation this week has decided that there will be a standard markup methodology for the supply chain of software, and to validate that, to make sure the licenses line up and the Git repositories and code base that do this. They've even agreed a form of RDF to do this. That RDF standard and, for example, taxation reporting standards mean we can compare vendors one against another. That's a really interesting thing. We can start saying as a business, are we actually getting good software development from people, and we can compare whether they've got their supply chain under control. But interestingly, we spread our desiderata and the associated analysis of this desiderata, the intents of what the software should do, across many systems, and we don't align them with the software development and the validation and the verification of those things that happen. We've also talked about chunk sizes throughout this. Parallelism definitely is easier with small things that we can parallelize, and we missize them, and we implement what the implications of executing. But there are plenty of things where the cost of standing up the environment for construction or the environment for verification or validation actually means that the big cost in resources isn't in the chunk size, it's in the cost of the supporting environments to do these things. And that cost is something that clearly we need to address. And that's sometimes addressed by caching. And are we caching the right things? Again, we don't have a model that lets us look at that to argue and reason about whether they are. And certainly we have distributed possible truth. The source code is not the only truth. The source code has to be supported by artifacts produced from it that align and are well lined up. Interestingly, lots of artifact repositories are now in third-party tools. Why aren't we putting them back with, for example, Git LFS, back in the same source code repositories? We appear to be dedicated to putting them other places, and, you know, that has some implications on what goes forward. So is that helpful? If we want a model, we want to be able to extract data from it. To extract data from it, we need to understand where that data is valuable. All the talks this morning have talked about cycle times. It's that speed at which we know we can get a merge in, the 10 minutes. The cost of resources and the resource consumption is something that we all could measure, but very few people do it. I've been working on problems recently where people have seen a 2 to 3 order of magnitude cost increase as they parallelize things, and those are not matched by the final business return values of what they're developing. That resource consumption cost makes them look at these things. There are lots of people who want to take complexity measures from software. I'm very wary about them. I'm unsure about the value associated with them, but certainly we can extract them today. There are also source code metrics we can do. For example, there are a number of CVE counters, library updates, and so on that we could take from the software bases that we play with, and we can say, so long as these aren't here, we are getting better software out of them. But that moving to the latest release of PHP, the latest release of Java, whatever, all comes with impacts about integrating those things and doing them again. And with systems at scale, we should look at how long it takes to do that. That gives us some source code and some background metrics. What possible insights could a model give? Well, it certainly can help with the process of steering delivery, and that's become a crucial issue. It should help us find where our effort should be spent. That analysis on run times is certainly valuable, but analysis on cost may be more valuable. Is construction where the most optimization should occur? Is verification where parallelization is most useful? Certainly in recent builds for me, parallelizing where I can verify things shorten the elapsed time, which gets me down to the numbers that we need to do these integrations. But do we have a better way to relate change to verification? For example, is there something we can say that through static analysis, actually, these are the only tests we should do? We've changed this code base. We know historically that code base, the objects behind it haven't changed. So only the things we need to do is where the objects have changed, and then we only need to run them on that space. So we're doing less analysis. Few people are looking at this, and it's certainly not something today models give us insight into. Why is the analysis of projects so expensive? Is it so expensive? Is our problem actually construction integration times, the point at which we can get a validated product back to our stakeholders? Again, we're not validating what's delivered for the organization and whether it's valuable. So it's not just the construction process, but it's also the tooling of the construction is a problem for people. Are we spending so much on delivering our software? Are we just blind? Effectively, we've got a sunk cost bias on the way we do software today. It's going to be complicated. There's going to be large things, and we're not looking at it again. We could do with a model that looks at this. When we come to the act of software build, we're conflating a number of operations together, I think. And it's not just always in the tooling, it's in the mind of the people who are solving the problem. There's a conflation of orchestration of environments with the act of constructing the software. That conflation that construction involves orchestration is misleading. I need the orchestration first, and I may do that in a number of different ways depending on the platform I'm working on. But we do conflate it. There is conflation between verification, the act of executing tests that return expected results that allow us to give a deterministic response so that we know that the product is behaving in known limits. But that's different about whether it's legally and officially accepted by the bodies in which it's used. And in fact, those come further down the line in increasingly regulated industries, particularly where I'm working in high-speed trading. That's becoming a big question. Can these trades be legally accepted, and do we have the evidence that they're legally allowed? We're conflating that behavior and we're leading people on with it. Today, elapsed time for delivery is uncertain. Even on the talks today, I think one of the things that's clear is that we go, yeah, we think we can get things built with some certainty in 10 minutes, but actually the long-term certainty involves these longer cycles. As the Arriva guys have just said, they were talking about actually confidence intervals on what delivered. I think that that's a really sharp approach, but we don't have a model to give us those confidence intervals and to think about it. The risk about delivering software is incomplete. I am not sure we have a complete model to address it, and it's frequently fuzzy. I'm absolutely the world's best at drawing a scripty picture on the screen and saying it's gonna be something like this, but actually to quantify it and to assess it in terms of these things is a big problem. I'm certainly watching businesses simply double their resource, increase their spending in the cloud, and they believe that this will make things better. But actually, what that leads to is buyer's remorse in the tooling and sunk costs in delivery bias, because it may not do it because people haven't done this thinking about segregating of what they're doing and where these things do. I'm watching very senior people really begin to regret what they've done in retooling. They think it was better historically. Again, because we don't have these metrics, because we don't have this model to see this improvement as a whole, we've no way to call them out. And in fact, there is a halo effect about how it was in the past rather than how it is now. Managing that without a model is becoming a real problem. So where can we learn from to put this model together to make things possible in a new way? Well, I always point people at the 12-factor app. It's an approach to thinking about how to break these things up into new worlds. And I think particularly its approach to hanging these things together has value and is an approachable way forward to these things. I think it's worth looking at regulatory frameworks where people need to provide evidence about what they do. And please, though the safety regulatory framework is well there is now a growing security regulatory framework, and particularly in the banking markets in which I'm working, there are new frameworks coming in place about core infrastructure that are running in that will be standardized. So actually understanding the infrastructure on which you build things and how you construct things will become part of the regulatory framework. And so being able to look at how those standards are being written and what they're being to ask will get us to think again about how we're delivering software. I've already mentioned that Google have decided STPA is the way to think about complex problems. I think people from MIT and people from NASA would agree. I would too. But these systematic approaches are being used for the product of software, not for software systems as a whole. And in fact, because we don't have a model, we can't build a WHO surgeon's checklist that we've done appropriate things. There is no debate around what those appropriate things are so that we make sure we're not shooting ourselves in the foot as software becomes the key of what we do. I think there are some really interesting problems that are small and addressable immediately. And the obvious one is the unit of work problem, the bin packing problem. You know, the smaller the unit of work, the easier it is to distribute it and parallelize it. But actually, for many people, when you talk about remote compilation, they're really talking about GitLab runners. They've got a resolution that is the whole repository. They've missed the pleasures of disk.cc, which is where my career began, or what Microsoft have been doing with Build Excel, and how that they're beginning to parallelize that for their DevOps platform, and particularly for their FAS platform as these things become necessary. But REPI has also got people thinking about what the smallest unit of work is and what the cost of the construction is and those environments. And the cost of the environment orchestration to stand those things up is still a debate, as raised earlier in today's talk. The cost of orchestration of these constructions and the verifications may not be the big problem. But if we can assist with test avoidance, because we know the dependencies, then maybe we can get away with even less orchestration. We can reduce our costs, and this whole bin packing problem becomes even easier. We don't need to pack so much. We can just do less testing. I have no idea what the model looks like. One of the attendees here today is Chris Pang. Another one is Emma Hickory. And in fact, one of the slide I've got in front of you is a bunch of conversations that we've had as a group about where these are going in terms of what we need to talk about in such a model. We talk about this relationship about the risk management of the system, its integration, its implementation, its verification and construction. And we talk about the need to record its dependencies. We've even talked about some of the metadata that hold these things together. But actually, when I go and talk to other people about this problem, it's not on their forefront. They're busy with dealing, I just need to make my build faster, rather than thinking, what can I do that's more effective to get the end results? Do I need to do as much building? Can I rely on other things to get these things done? And actually, part of building software at scale is to have these conversations and think about what the model might look like. What sort of things do we need to address? In the chat of the last talk, I mentioned a couple of things about dependency recording, a piece of work that Finn Ball and Chris Pang and myself have done on managing Git dependencies by using metadata within Git and managing those cross dependencies reliably. But also, there are dependency recording for what the environment was on. One of the things that the very first talk today raised was you can't have the inability to reconstruct things as they were. How do we know we've got a reproducible environment without some verification and appropriate validation that that was enough to do what's going on? And again, the validation about other things that we require to produce the systems in production. One of the problems that I've had, particularly recently in the pharmaceutical industry, is that the validation of systems is still done with actually a spreadsheet and a person who ticks things off. And the system that really runs in production, there is no way to humanly access it. There is no SSH way in. There is no access to anything but the source code. And educating the people who do these validations for the legal frameworks meant that I had to educate them on how I got the dependencies in and how I constructed systems. We're going to have to be able to do this dependency reporting in a way that allows this validation without people physically touching these things. And there's more to be done there. Again, we have to record the artifacts, not just the source code, but the desiderata, the requirements, the intents, the how we believe it should be. We have the implementation, the change sets that we do, and the appropriated integration. But I'm amazed how often I go back to look at code and we agreed we integrated it, but I can't reproduce the verification data close, let alone identical to how it worked. And debugging why I can't do that is fascinating. The data sets evolved, the tests changed, the equipment no longer is manufactured, the chips are no longer available, all of these things. And so I just have to hope that they got in correctly. So, to summarize, we're doing the actions of construction, hoping that the results will be okay. In fact, we have no way of doing it. We have a whole bunch of missteps around the requirements of build tooling. We have a whole series of buzzwords: fast, complete, reliable. And in fact, we've not got good definitions around them to hold them together. And we're missing subtle distances between why construction, which is done in an environment with the construction tools, is not, for example, appropriate when we come to validate, because in the validated environment, we would never have the construction tools available to us, and those environments in which those things done aren't available in that environment and should not be available. We lack measures to assess what's happening. Actually, the only measures we have is perhaps cycle time reliably, but we don't have cost measures. We don't have utilization measures. We don't have impact measures. So if we're going to address these, what we want to do is normalize the interfaces and clearly state the requirements of what build systems and what measures hold them together. And this talk is really to say, we need to address those issues. We should start thinking about them, about where to hold them together and why they have value going forward. Thanks very much for your time. I hope that gave you a picture of where this is going.
So thanks a lot for your talk, Edmund. So I had one of the questions, and maybe it's a pretty vague question, but maybe you can give a really concrete answer to it. One of the things I've observed is that at some point, like, IT is becoming so complex that it takes more than a lifetime to sort of get more knowledge on it, right? And I think also with like an increased set of like potential business processes or, you know, things that are only rolled out locally within a certain organization, but we're never going to get there. What kind of projects can we work on, like that will basically solve the problem for everyone on Earth without needing to invest in it themselves, right? So it's a bit of a vague question, but hopefully the message comes across.
I mean, I think that one of the key factors that we've learned from open source is actually scratching one's own itch may involve others that get involved. And so scratching my own itch about the cost concerns of delivering build systems and SDLC for organizations has meant that other people have said, well, okay, what metrics can we do? For example, the cycle time metrics, people at least talk about. They've been used on the talks already today, but people aren't using the cost metrics. And actually, people are very wary about showing those cost metrics. I did some work for a car manufacturer where it was impossible to say what the real metrics were, but we could say it prevented the cost of the build system meant that they did not have enough resources to get another 2,000 cars a day off the pipeline.
Yeah, exactly.
And those sorts of things to hire people really grab the debate and they start thinking about them. I think also there's a whole bunch of technology. I'm fascinated by how much static analysis has come back into flavor and how I can start doing the static analysis to look at where I should verify things. And that has real value because I can now make decisions about whether the code, because I have the cached O files, if the O file hasn't changed, maybe I don't have to do the run. Does that make sense? And so I don't have to do the verification. I only have to verify the other things. But that's a risk-based approach. So the question is, how do I assess the risk for that as a system as a whole? I think systems like STPA give us a way to do that, but actually we should be doing it not just for the code that runs through it, but for the system that delivers it. And we're not doing that.
Well, that's a pretty good answer. Unfortunately, there aren't any other further questions that have been posted into the chat. Before you leave, Edmund, I really want to thank you for your talk. It's been really interesting, and I really hope that like some of these process improvements will like slowly start to trickle into our industry because it's really needed. Yeah.
Thanks again.